Okay, in this example, we're going to try to solve this polynomial equation x to the fourth minus 3x squared minus 4 equals 0. This is factorable. It might be a little difficult to see that at first glance. So what I'm going to recommend trying to do here is making some substitutions. In order to see that, I'm going to rewrite this x to the fourth term using some properties of exponents from Algebra 1. X to the fourth could be rewritten as x squared squared, like that. When you take something to a power to another power, you multiply their exponents, so that would give you x to the fourth. So I haven't really changed the value of anything, I've just changed the way it looked for us. Going ahead and filling in the rest of this, minus 3x squared minus 4 equals 0, like that. And you're like, well, what did that do for me? Well, that might make it look a little bit more confusing, but what I'm going to suggest next is that we make a substitution so we don't have to have these high powers on variables. That we let maybe the letter u equal x squared. So what I'm suggesting there is I'm suggesting that you make a substitution. Everywhere that you see x squared in this problem, you replace that with the letter u. If I do that, instead of x squared squared, I'll just have u squared minus 3u, instead of x squared, I'll just have u, minus 4 equals 0. And looking at that, that looks a lot like a quadratic trinomial that we've seen in previous units. I can go ahead and factor this. I can find two numbers that multiply to negative 4 that also happen to add up to negative 3. So I'm just going to go ahead and try to factor this into two binomials using the u here. So I have u and u for the u squared. And numbers that multiply to negative 4 that also happen to add up to negative 3, well, that would be minus 4 and positive 1, like that. And I've taken care of the factoring. Now I'll go ahead and substitute the x squareds back in for the u's. Instead of having u, I'll go ahead and put x squared back in that spot. Instead of having u here, I'll go ahead and put x squared back in that spot. And you can see that I have two quadratic binomials here, one of which is a difference of squares, one of which is a sum of squares. So I've ran out of room here, so I'm going to jump back up to the top of the board here. I had x squared minus 4, and I have x squared plus 1 equals 0, like that. Again, some people are certainly able to keep track of that substitution step in their head and go right from here to here. I certainly could as well. I'm just kind of showing you what's going on behind the scenes there. But once you get to this point, you just set each factor equal to 0. I have x squared minus 4 equals 0, and x squared plus 1 equals 0. Recognizing that this is a difference of squares, I could factor it as x plus 2 times x minus 2. Recognizing this as a sum of squares from a previous video, I could factor this as x plus 1i times x minus 1i. And then again, I can take advantage of the zero product property here in both of these cases to set each of these factors equal to 0. So I have x plus 2 equals 0 and x minus 2 equals 0. I have x plus I equals 0 and x minus I equals 0. And solving each of these in one step of algebra, I can get that x equals negative 2 and x equals positive 2. And then over here, I can get that x equals negative I and x equals positive I. I can write this as x equals plus or minus 2 and plus or minus I for my final solution there. So a little bit of a trick there using substitutions to maybe make those powers a little smaller so you can connect it back to the previous factoring problems that you've done. But we can certainly factor these higher powered trinomials if they have that same structure. Notice that the exponent on this first term was twice that of what was on this middle term, and then this one didn't have any. So it still shows that structure like you might be used to when you were factoring things like x squared plus 5x plus 6 or something like that. I'll have you take a look at this one next. X to the fourth minus 5x squared plus 4 equals 0. See if you can make use of that substitution trick that I just showed you in the previous example, and then check it against my work on the slides that follows.